Hello everybody. Today we'll cover a part of real numbers, which is the first chapter of Maths class 10th NCERT. So far you have studied rational numbers and irrational numbers. Let us have a fast recall of these numbers. Rational numbers are those numbers which can be expressed in the form of p by q, where p and q are integers, such that q is not equal to 0. Alright, and minus 2 by 5, 4 by 7, minus 5, 0, 1, etc. are the examples of rational numbers. Now, what are irrational numbers? Those numbers which have non-terminating and non-repeating decimals. They are called irrational numbers. For example, root 5, root 2, root 5 plus 1, 1.40, 400, 4 dot dot dot, etc. These are irrational numbers. Alright. So when the families of these numbers, the rational numbers and irrational numbers, they are merged together, they enter into a larger family of numbers, and that family is called real numbers. Alright. Now when we begin the chapter, we come across an important property of integers, that is Euclid's division algorithm. Why we are talking about integers? Because integers are rational numbers, so integers are also real numbers. Alright. Now, Euclid's division algorithm simply states that any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder r, such that r is smaller than b. Let us take example of two numbers. Suppose one of the numbers is 10 and we take another number as 8. Alright, and let us divide 10 by 8. 8 ones are 8 and the remainder left is 2, which is of course smaller than the divisor 8. Alright. Now, when we come to the application aspect of Euclid's division algorithm, we say that it's a technique to find HCF of two numbers. Alright. Now how we find HCF of two numbers in this technique? To know that, we must go through a lemma, that is Euclid's division lemma, which states that given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, such that r is greater than or equal to 0 and it is smaller than b. Alright. Now we come back to the same example we had taken and put the values here in this relation. What do we get? 10 is one of the integers we took. 10 is equal to the second integer we had taken was 8. So 8 q, 8 into q. So it should be 1. Q is 1, 8 into 1 plus the remainder 2. Alright. We see that 2 is smaller than 8. Alright. This is the same thing we had learned in lower classes, how we test whether our division is correct or not. We write dividend is equal to divisor into quotient plus remainder. Right. Now, this is the lemma we are using in division algorithm to find the HCF. But how it is done? So for that, we observe that we are having the present divisor 8 and the remainder is 2. Alright. So the present divisor becomes the dividend and the remainder becomes the divisor, and we divide. 2 4s are 8 and we get the remainder 0. Now rewrite this using this lemma. So 8 is equal to 2 into 4 plus 0. Now you see how when we got the remainder 0, then the divisor was 2. Then 2 is called the HCF of the numbers 10 and 8. So it strikes to one of the methods we have studied in lower class of finding the HCF by division method. Suppose same numbers I am taking. Suppose we have to find the HCF of 10 and 8. 10 and 8 using long division method. Then what we do? We write the larger number as dividend and the smaller number as divisor, and we divide. 8 ones are 8. 2 is the remainder. Now this remainder becomes the divisor and the previous divisor becomes the dividend. 2 4s are 8. We got the remainder 0. So the last divisor in this process is 2. So that is the HCF. So this way we can find out the HCF of any two numbers using Euclid's division algorithm. That's all for today. Thank you.